Zometric is a web-based multi-tenant software for Industry 4.0. We have various modules within Zometric. In this session, we will focus on a real-time SPC module and a statistical analysis module. Within real-time statistical process control module, we start with some bit of configurations like different factories, different production equipments, parts, units of measurement, sampling frequency, variable characteristics, specifications, defects, defectives. Once the configurations are done, what we get is a list of schemes. Each scheme is a combination of one production equipment or a process, a part, and a test or a parameter. The test or a parameter could be a process parameter or it could be a product characteristics. Let us say I am an operator and I see the screen. All that I need to do is select the machine that I am currently operating. Let's say I am operating machine 1. Machine 1 could be producing various parts. Let's say I am interested in one of the part. So I filtered the parts and the machine, and then there are various parameters. Out of those parameters, some of them are attributes, it could be defects or defectives. Some of them are variables. They can be either as individual variables or subgroup variables depending on how I'm collecting my data. Let us say I'm interested in one of the parameter related to the part DNCF 1818 black being manufactured from machine 1. Let's say I want to capture data for fabric strength weft. When I land up in this page, at the top of the page I see a table which describes the machine that I'm operating on, the name of the part, the variable, the specification limits pulled from the masters, and if the historical mean and sigma was already defined, we could see that. In this scenario, we have not fixed the historical mean and sigma, so the control limits are calculated dynamically. If the historical mean and sigma were fixed, the control limits should have been fixed. I can see an eye chart and an MR chart, and on the right side I am seeing a data capture form where as an operator I can enter data one by one. Let me enter some data. Let us say my data is 117.2 and there are certain optional fields like batch number, lot number, remarks, operator, inspector, gauge. If I want to enter these values, I could enter, otherwise I can just submit it. So when I submitted this data, you would see that the graph got updated right in front of my eyes. So in case there are any statistical rule violation, I will be able to notice them right then and there instead of waiting for an analysis to happen at a later point of time. As an operator, if I look at these control charts, there are two benefits that will happen. First, I will remove the guesswork for me to set the machines or do the adjustments within the machine. I will not take an action unless I see a real instability in the process. Second, I will do the adjustment whenever I see a trend or any sudden deviations from in the process like rule 1 or rule 5 is a trend. I will take appropriate actions whenever it is required. By not taking action through guesswork, I am actually reducing the variation and also helping improve the productivity. But usually what happens during a manufacturing process is I do not measure only one variable, I measure multiple variables. In Zometric, all the related variables are all arranged in the quick navigation. So I can select the next variable that I'm interested in. Let's say the next variable that I'm interested in is fabric strength warp. This is a different variable with a different specification limit and different control limits. In this scenario, my historical mean and sigma is fixed. So based on the historical mean and sigma, my control limits are also fixed and I can see certain uh, Nelson's rule. All 8 Nelson's rules are available within Zometric. It is up to me or the management to decide which rule to be activated and which rule we can deactivate. I can navigate to another variable, for example, weight per square meter, GSM. Here you will see it is asking me 5 data points. This is because this is an X bar R chart. Since we have set the subgroup size to 5, it is asking me to enter 5 data points at a time. This not only helps organize my control charts and SPC program, it also reduces the need for training the operators as well, because somebody sitting centrally can configure all these subgroup sizes and the sampling frequencies, and the operator on the soft floor, they just have to follow the standard that has already been set in the software. Now coming back to the IMR chart that we were looking at. One is collecting data in the real time. If I want to do a further deep dive and analyze how my process has been behaving, I can do a deeper analysis in the analysis section. By default, I am seeing a capability histogram and certain CP, CPK, PP, PPK, sigma levels and PPM levels. If I want to get an analysis for any specific period of time, since the data is stored within the software, I can select the time period that I'm interested in. There are certain options. I can select those options if required, and I can submit it. So when I submit it, I get an eye chart, a capability histogram, a moving range chart, a normal probability plot, last 25 observations, and my capability report. This is a pretty popular report called Capability Six Pack. So all the required analysis is all available in one place. Remember, Zometric is highly interactive. So if I want to drill down and understand what happened in a specific period, I can do that in a very interactive manner. Apart from this, there are various advanced analysis that is possible. For example, I have done some improvement in a process and I want to know whether the improvement action that we took, did it really create an impact, or was it just random? So I can select two different time periods. One is called the reference, another is called the compare period. So I am selecting two different time period. I can compare across machines, or I can compare within the same machine two different time periods. So when I analyze this data, not only it analyzes the data for me, it also gives me an interpretation. It is saying the process mean did not change significantly because the p-value is greater than 0.05. However, the process standard deviation changed significantly because the p-value is less than 0.05. Now it shows me a side-by-side comparison of the equipment that was used, the part, the variable, the from and to time, the min, max, mean, standard deviation, CP, CPK, all the calculations are available side by side, and I can also see a graphical analysis of of the analysis that we are doing. Apart from this, there are various other analysis that is possible. Since the data is stored within the software, a lot of analysis is possible that we can directly do in the software. Now coming back to the data capture, we demonstrated how we can capture data one by one. There are situations when I need to collect data in groups. For example, I am running a coordinate measuring machine and it is generating multiple parameters or multiple variables data for me. In such a scenario, I can enter the data manually for multiple variables together, or I can copy and paste the data from another Excel sheet or something. So I can copy it and I can paste it here and I can submit it. The values will go and sit in the respective control charts. Again, coming back to data capture, whenever any Nelson's rule or statistical rule is violated, the subscriber to the process, whoever have subscribed to the process, will start getting email alerts. So this is a great advantage of doing uh, or operating a real-time or an online SPC program, because you're able to get an intimation when your process goes unstable and you can take action immediately. Apart from this, all the data that we are recording is all available for download in Excel or CSV format anytime that we need. And in case we find any special cause, we have the ability to record those special causes. By recording the special causes, we have the ability to analyze those special causes and take preventive actions in future. So this is in brief, we have touched upon some of the features of the real-time SPC module. Now let us look at the capabilities of the statistical analysis module. While in real-time SPC module, we were able to store the data within the software in a cloud or in a central server on an on-premise setup. In the statistical analysis module, we are able to do very advanced statistical analysis module, whether the data is stored within the software or if it is not available in the software, we can take the data from any spreadsheets and we can do the analysis. We will see a couple of examples. What are the tools that are available in the statistical analysis module? It starts from very basics like the graphical analysis like pie chart, bar chart, Pareto chart, box plot, density, heat map, scatter plot, correlation, histogram. We can also do normal probability analysis, descriptive statistics, graphical summary, multivariate charts, to little more advanced things like box House transformations. Of course, control charts, we saw a couple of control charts. Similarly, there are process capabilities and hypothesis test. Let us start an example of a hypothesis test. Let's say two sample t-test. Within Zometric statistical analysis module, either I can copy and paste my data from any spreadsheets, or I have certain data which is available as load example. I can load those example. It will give me a scenario and it will load some data for me. There are certain options in the right. I can hit a calculate and I will get my results. My results include graphical analysis as well as certain statistical analysis. For example, it has created two box plots and certain individual value points for me and also generated certain statistical calculations. Let us say I do not understand what a two sample t-test is. I do not know what is the meaning of a t-value, what is the meaning of p-value. I can ask any question to Zometric AI to help me understand the results. For example, in this scenario, there are two formulations and we are trying to compare which of those two formulations are better from the growth of rate of growth of plants. So these are two fertilizers, right? So I am asking a simple question, which fertilizer is better? Now Zometric analyzes the results, statistical results, and it understands the context and it is responding. It is saying based on the results of the two sample t-test analysis, there is no significant difference between the growth of rate of plants treated with formulation A and formulation B. The p-value of 0.9525. Where did this number come from? It comes from this statistical analysis from here. It is not a generic answer or a response. It is aware of the context, it is aware of the statistical analysis, and then it is responding. It is saying 0.9525 indicates that we fail to reject the null hypothesis, which means there is no statistically significant difference in the growth rate between the two fertilizer formulations. Okay, let us take some more examples. This time let us take an example of a capabilities, or let us take an example of a gauge GRR. Let's say crossed GRR, right? So here also let's load an example. In this example, what we are doing is we are taking 10 parts and we are taking three appraisers, and each appraiser is checking each of the part three times. Let me put an LSL, let's say minus 2.16 and 2.26, and there are certain values here. There are certain other fields. If I fill up these fields, all these fields will appear in the report so that I do not have to edit those reports manually, and I can generate the report and send it to my customer or file it somewhere that I need. So when I calculated, I got my gauge R&R table, my components of variation, measurement by part, measurement by operator, part operator interaction, R chart by operator, X bar chart by operator, and two-way interaction, two-way ANOVA table with interaction, two-way ANOVA table without interaction. And if I want to ask any question, I can ask it. Like for example, I do not want to look into all this data. I just want to ask a simple question. What is NDC? So it is saying NDC stands for number of distinct categories. In the context of a GRR study, NDC indicates the number of distinct categories levels or levels that can be reliably measured by measurement systems. An NDC below 5 is typically considered not acceptable, right? And it is showing that in the provided analysis, the NDC value is 4, which suggests that the measurement system may not be reliable enough to distinguish between different categories. Let's look at a little more advanced analysis, for example, a design of experiment, right? So for this experiment, I will need some factors. So I have selected certain factors here. Some are attribute and some are variable. The first thing I will do is fetch design options. So I have fractional factorial resolution and full factorial. I will stick with the fractional factorial and I will create a design. So when I created a design, I got a set of combinations of material, injection pressure, injection temperature, cooling temperature. Those were the factors that I had given here, and it is allowing some space for entering the results. Let me copy some results from here. So I copied some results. Now I can select certain terms. It analyzed those results and it created a regression equation for me, including the terms that I wanted to be included. And it has done some ANOVA and it has done a Pareto of standardized effects. It is saying my material and injection interaction is not significant. So maybe I can remove them and I can try to analyze again. This time my standardized effect is saying even injection temperature and cooling temperature are not significant. So I will select only these two. And finally I arrive at a situation where all the terms that I am looking at are significant, and I get my final regression equation, which should reliably predict the behavior of the result that I am looking at. So there are various tools like this. We can use these tools especially for Six Sigma related programs. Also, all these analytical capabilities exist as APIs, which means tomorrow if we need any kind of analysis, for example, correlating two different variables or correlating a machine parameter with a certain quality or a product characteristics, all of these things are possible. We need to look at the scenario and we can analyze those results. Now coming back, there are various other modules, but in real-time SPC module, we are able to store data, and the method of entry of data into the real-time SPC module is either through manual data capture, semi-automatic data capture, or automated data capture. What we mean by manual data capture is some human being is entering the data into the software. By semi-automatic, we mean some gauges which are either connected to the software through wire or a Bluetooth connected device. We are able to collect the data directly from the instruments or devices into the software. By automatic, we mean we are able to collect data directly from any PLC or other SCADA systems or any other cloud-based applications which exposes APIs and push the data into the software, right? Apart from this, let's also explore the bulk data capture capability. In bulk data capture capability, basically we are able to capture the historical data or certain data which is being dumped from another system in large quantities. It's as friendly as copying data from a spreadsheets, filling up the required information and submitting it. The data will get saved in the system. Thank you.